Let us learn about product of two vectors. Multiplication of two vectors is defined in two ways, namely scalar or dot product and vector or cross product. Now we will learn about scalar or dot product of two vectors. Let us take two non-zero vectors a and b with angle theta between them, where theta varies from 0 to pi. The scalar product of two non-zero vectors a and b denoted by a dot b is defined as a dot b vector equals to modulus of a vector into modulus of b vector into cos theta. If either a vector equals to 0 or b vector equals to 0, then theta is not defined because 0 vector has no particular direction. Definition: the scalar product of two non-zero vectors a and b denoted by a vector dot b vector is defined as a vector dot b vector equals to mod of a vector into mod of b vector into cos theta. Observations: a dot b vector is a real number. A dot b equals to mod of a vector into mod of b vector into cos theta, which is a real number. Let a vector and b vector be two non-zero vectors. Then a dot b equals to 0 if and only if a vector and b vector are perpendicular to each other. That is, a vector is perpendicular to b vector. Then a dot b becomes mod of a into mod of b into cos of pi by 2. Now we know that cos of pi by 2 equals to 0. Then a dot b equals to 0. If theta equals to 0, then a dot b equals to mod of a into mod of b. In particular, a dot a vector equals to mod of a square, as theta in this case is 0. We know that cos theta equals to 0, then we can write a dot b equals to mod of a into mod of b into cos 0, which becomes mod of a into mod of b. Now, if theta equals to pi, then a vector dot b vector equals to negative of mod of a vector into mod of b vector. In particular, let us take a case. Let us take dot product of a vector and negative of a vector. It becomes negative of mod of a square, as theta in this case is pi, and we know that cos of pi equals to minus 1. In view of the observation 2 and 3, for mutually perpendicular unit vectors I cap, j cap and k cap, we have I dot I equals to j dot j equals to k dot k equals to 1 and I dot j equals to j dot k equals to k dot I equals to 0. The angle between two non-zero vectors a and b is given by cos theta equals to a vector dot b vector whole divided by mod of a vector into mod of b vector. Or we can say theta equals to cos inverse a dot b divided by mod of a vector into mod of b vector. The scalar product is commutative, that is, a dot b equals to mod of a into mod of b into cos theta, or a dot b equals to mod of b into mod of a into cos theta. Property. Let us see some of the properties followed by dot product of two vectors. Property 1. Distributivity of scalar product over addition. Let us take three vectors a vector, b vector and c vector. Then we can say that a vector dot b vector plus c vector equals to a dot b vector plus a dot c vector. Property 2. Let A vector and B vector be any two vectors and lambda be any scalar. Then we can say that lambda times A vector dot B vector equals to lambda times A dot B vector, or which is equals to A vector dot lambda times B vector. If two vectors A and B are given in component form as A1 I cap plus A2 j cap plus A3 k cap and B1 I cap plus B2 j cap plus B3 k cap, then their scalar product is given as A dot B equals to A1 I cap plus A2 j cap plus A3 k cap dot B1 I cap plus B2 j cap plus B3 k cap, which gives A1 I cap into B1 I cap plus B2 j cap plus B3 k cap plus A2 j cap into B1 I cap plus B2 j cap plus B3 k cap plus A3 k cap into B1 I cap plus B2 j cap plus B3 k cap, which gives A1 A2 into I cap dot I cap plus A1 B2 into I cap dot j cap plus A1 B3 into I cap dot k cap plus A2 B1 into j cap dot I cap plus A2 B2 into j cap dot j cap plus A3 B3 into j cap dot k cap plus A3 B1 into k cap dot I cap plus A3 B2 into k cap dot j cap plus A3 B3 into k cap dot k cap. Using the observation 5, we can see that A vector dot B vector equals to A1 B1 plus A2 B2 plus A3 B3.